okay, so one of the main things we do with differential equations is show that the given solution is indeed a solution to the differential equation. And if given a point, find the constant so we have a specific solution. Okay? Let's look at an example of that. Okay? Because your homework tonight is going to have you do that exercise. Okay? We'll look at a few examples here. Okay? So our first one, okay, is that example of a type of question you might get here would be verify, okay, that y equals cx cubed is a solution to xy prime minus 3y equals 0, and find the specific solution for that right there, okay? Y of minus 3 equals 2, okay? If you saw that, by the way, y minus 3 equals 2, what do you think that actually means?
Plug in
Y equals y.
Okay? It would mean, basically here, we're not used to seeing notation written like this, but if I replace the y with an f and made that f of minus 3 equals 2, what would that tell me?
It's a function.
Yeah, it's a function, right? It would tell me what x was and what y was, right? So what's x? Negative 3, and what's y? 2.
Oh, so that's just asking what's the equation
Yeah.
where...
So basically, this is really just saying...
What's the equation where x should be?
Yeah.
plug into.
So this is really saying if I plug in negative 3, I get 2.
Which
So-
equation?
X is equal to minus 3, and y is equal to 2. Okay? That's what this is really saying right there.
Like the solution would be a function?
Yes. Okay? Well, not necessarily, but that's what because you could have these things be implicit. You could have these things be like we looked at last year, where like circles and ellipses, and polar equations. Well, not polar, but that same sort of idea. Okay? But that's what we get right there. Okay? So we want to verify that this is the case. Okay? So this is actually really two questions in one. The first question is to show that this guy is indeed the solution to this guy over here. Okay? So all we have to do is basically just see if I can manipulate this to make this thing work, basically. Okay? Then the next thing is, if that indeed does work, we want to find what c is using these values of x and y. Okay? Because that would give us the specific c for making this thing work. Okay? So let's first start with the first part, the verify. Okay?
Wait, how did you get out of this got x?
This is all given.
Oh.
All of this is given, yes.
Okay,
This is like
yeah,
literally
I
the
have
problem in
no
the book.
idea how you got
Okay?
that.
Yeah. No, I didn't find anything yet. This was all just given. Okay? So this is one problem here. Okay?
Right.
But there's two parts to it. The first part is to verify. So let's verify. Okay? Now, we basically want to show we're given that y is equal to cx cubed. We're told that has to be a solution to x y prime minus 3y equals 0. Now, I can replace y with cx cubed, right? So that's what I'm giving right here. Okay? I've got a y prime now. So how can I, what's y prime mean? It's derivative of y, right?
So would you say derivative?
So can I take the derivative of this?
Oh, sorry, I'm wrong.
Yeah.
Yeah. What's the derivative of this right here?
3cx squared.
So it'd be 3cx squared. Good. Now I've got everything, I can put them into here and have everything in terms of a single variable, x.
So
Okay?
weird.
Oh yeah, this one's actually good. I'm glad you find this easy. It's actually not that bad when you learn what you're doing. Okay? So we do our replacements, so we're going to have then x times y prime is 3cx squared. Okay? We're going to subtract from that 3y, or 3cx cubed. Okay? Is that indeed 0? What's that come out to be?
0.
Yeah, that's 3cx cubed minus 3cx cubed, which is indeed 0. Okay. So this does work. Okay. So this is indeed a solution. Okay. We verify that it's a solution. Now for the second part. Okay. The second part is saying once we verify that this is indeed a solution, figure out what c is when x is -3 and y is 2. Well, do I have to do anything special there? I just plug in -2 and I plug in 2 and -3 into this thing, right? And solve for c. Huh?
For which part?
Oh, into our original equation. I could do it for the second one as well, but it's just going to give you 0. So we want to do it right there. Okay? Well, if I do that, y is equal to cx cubed. Okay? 2 then is equal to c times -3 cubed. What's -3 cubed?
-27.
-27. So we get 2 is equal to -27c. So what's c going to be then?
-1 or
2 over -27.
27.
Okay? So we found what the constant was that makes this thing work. So what we've done here is we basically said that y equals 2 over -27 times x cubed is a solution to this differential equation that goes through this point right there.
Wait, so why are you allowed to plug in that 3 without y? You just need it straight for that.
Well, what's x?
Yeah, why don't you give it to
Oh, I could, but what's that going to give me, Jim? What's this tell me? The derivative, if I plug things into it, gives me 0. So,
I'm talking about when you plug it, like, why would you plug it in 3cx squared?
why would I plug it in there?
Yeah.
Because, again, I'm given that y is equal to 2. I don't know anything about y prime yet. Okay, if I did that, I would just know that y prime would be 3 times c times 9. So it would be 27c is what y prime would be. Okay? Well, that doesn't help me very much if I don't know what c is. Okay?
So why did you think the derivative of y equals 6 cubed?
Why did I do that to begin with?
Yeah.
Okay, again, there's 2 parts to this problem. The first part is to verify.
Yeah.
Okay. Well, in order to verify that this was the solution of this over here, I had to basically be able to do things with this to show that this indeed worked. Well, I've got what y is, cx cubed, so I can replace that y with cx cubed. I don't have what y prime is, but I can figure it out by just taking the derivative of that, right? Which is what I did, plugged everything in terms of x, and then saw, hey, I got 0, so the thing must work. Okay? And then the second step was, with this given point I had, show indeed, figure out what c is. Okay? Let's look at another example like this. Okay? And this is going to be like one of the ones from the homework tonight. Okay? We're going to have here.
So you're done after you get to the C?
Yeah, because all we're doing is verifying. Verifying and then figuring out the specific solution, which we did. Okay? Yeah, so that was it. That was it. Not hard, right? All right. This is going to be a harder one, but this is about as difficult as they're going to get for us. Okay? This is number 10 in your book. Again, we're told to verify that the specific solution works. Okay? Okay? And so here's what we're given. We're given our solution, which is going to be y equals 1/2 x squared minus 2 cosine of x minus 3. Okay? We're given a differential equation, which I'm just going to abbreviate DE, okay, here, of y prime equals x plus 2 sine of x. Okay? And then we're given a point, basically, and it's written as y of 0 equals -5. So, what that means is that when x is 0, y is -5. That's what that means there. Okay? So, what we want to do is we just want to verify that this is the case, okay? That all this information makes sense.
What did DE stand
What's it stand for?
for?
Differential equation.
Differential equation. Sorry, I said that when I wrote DE. Okay. But I was going to abbreviate it because I didn't want to write differential equation.
It's just blank or something.
Okay?
Wait, this is given right there?
Yeah, all this is given, yes. Sorry. There we go. Better? Yeah. All this is given. So all we're doing here, everybody, is we're not solving for anything here. We're verifying, which means we're just showing that all this is indeed true. That's all we have to do here. Okay? So, to show that it's true, the first thing I want to start with is to see is this solution, is its derivative the differential equation in question. Okay? Well, let's do that. Okay? So we'll say step 1 here. What's the derivative of this guy?
X plus its prime.
My prime would be 2 times
X
1/2 times 2x minus 2 times, what's the derivative of cosine of x? Negative sine of x. What's the derivative of minus 3? 0. Okay? If we clean all that up there, that cancels out, giving me just x. Minus 2 and minus sine give me plus 2 sine of x. And the 0 goes away. So, what we're given is indeed a solution. Okay? And it is indeed a specific solution to our differential equation. Okay? All good there, right? That's all we had to do. Show that it worked. It works. Now what we're going to do here is we're going to say, okay, does this given point work? Okay? Well, let's plug it all in. Okay? I'm going to just make y negative 5 and x 0 up here. So if we did that, we'd have negative 5 is equal to 1/2 0 squared minus 2 cosine of 0 minus 3. Okay? Well, 0 squared is
0.
and 0 times 1/2 is
0.
0. So that goes away.
Can you put all that into the original?
Just the original. Now, here's the tricky part, and it's only tricky because some of you probably forgot your trigonometry. What's the cosine of 0?
1.
It's 1. Okay? So negative cosine of 0, or negative 2 cosine of 0, would just be negative 2 times 1 minus 3. And so is minus 2 minus 3 equal to negative 5?
Yeah.
Yes, indeed. Okay? So indeed, that point works. Okay? And so that's all we had to do. We just had to show that these things indeed worked. And that was the entirety of the problem. Okay? Is that hard? Is that bad?
No, sir.
No, it's pretty straightforward, right? And so a lot of times when you're doing these differential equation problems, you're just verifying. You're just showing how these steps come out to be. Okay? Any questions there? All right. Let's look at one that's going to be a bit more difficult. Okay? And this one's going to be more difficult simply because there's going to be a lot more steps involved. All right? In trying to make this thing work out. Okay? And so it's just a matter of a lot of times when you're doing these verifying steps, when you're doing these verifying problems with differential equations, it's all a certain level of bookkeeping. Okay? What I mean by that is just keeping everything straight and having all your steps clearly labeled. Okay? So in this case, we're going to verify that y equals c1 e to the negative x, okay, cosine of x, plus c2 e to the negative x sine of x, okay, is a solution to y prime plus, sorry, y double prime plus 2y prime plus 2y equals 0. Okay? Big and nasty looking, right?
Because C1.
C1 and C2. Okay? So there's two different constants here. So this is a general solution, supposedly, of this thing. We just got to show that it indeed works. Yep.
It's a C.
Yes, C1.
Will you ever have something this hard?
On an AP test, probably not. On one of my tests, I'll get probably not, okay? Mainly because this isn't particularly hard, it's just long, as you're gonna see here as we start to do it. It'll just take a while to do. But I'm gonna do something as I go through it and show you a way to make this easier as you do it, okay?
Okay.
Alright, so, we've got an equation, okay? And we need to check to see if it makes this thing over here work. And my solution makes this work here. So, I've got what y is. Y is all of this.
Take the derivative of it.
I need the derivative and the second derivative of it, don't I?
Yep.
Okay? So let's start off with the first derivative. Okay? Come on. Thank you. Y prime is going to be what? Now, up there, each of those things are going to be chain rules, correct? Not chain rules, sorry, product rules. Okay?
Isn't that related?
So, product rule says, derivative of the first thing, keeping the second one the same, plus first one the same, derivative of the second. So what's the derivative of c to the first, c sub 1 of e to negative x?
Negative.
C sub 1, e to negative x
Negative.
times negative 1. Derivative of cosine of x is?
Negative sine.
It's
Oh, the.
minus sine of x, you're right, minus sine of x.
But doesn't it stay the same? Wait, what are you doing?
Oh, that one does stay the same, thank you. I'm being dumb. Okay. Plus,
Where does that negative one come from?
Negative.
it's the
minus
derivative of e to
Negative
negative
x.
x. It's e to negative x.
Oh, and then the derivative
times the
of-
derivative of negative x.
Wait, why does it stay cosine again?
It's product rule.
I feel that.
That's a product rule, isn't it?
Why are all these like rules
Okay.
coming into play, bro?
Because,
Minus
Jim.
x,
okay, times negative sine of x now. Okay, because that's what the derivative of cosine was. Hang on, I need some space. This is too high. Okay? Then we'll do the same thing over here. Okay? So this would be plus derivative of this guy right here. So c2 e to the negative x times negative 1 sine of x plus c2 e to the negative x cosine of x. Okay? I'm going to take a step to clean this up here. So we got minus c sub 1 e to the negative x cosine of x minus c to the negative 1 e to the negative x, okay? Plus, okay,
Well, you missed some.
minus, thank you, c2 e to the negative x sine of x plus c2 e to the negative x cosine of x, okay? Now,
Forgot the first one.
You don't have to have brackets around.
thank you.
Wait, why?
What do you mean brackets?
Why would you put brackets in the first product rule and the second product?
Oh, we could if we wanted to, but I mean, you know, as long as we keep our signs straight, we're fine.
This is.
Okay? But, and here's why I'm not going to do that here, okay? Let me reorder things slightly, okay? Just to clean this up here, okay? I'm going to leave this guy where it is. I'm going to move this guy up front. So it's going to become minus c2 e to the negative x sine of x, okay? Then this one right here just becomes the next one. Followed by this one on the end. Alright. Now, why did I do all that? Why did I reorder this thing? What's all of this right there, actually? Look above. It's y, but not just y, it's negative y, isn't it?
Yes.
Okay? So by reordering everything, I was able to take half of this derivative and replace it with what I originally started with, that y. Okay? Which means that y prime then is equal to y minus c1 e to the negative x sine of x plus c2 e to the negative x cosine of x. Okay? And that's much easier to deal with, right? When I'm doing a second derivative. isn't it? What else could I have done here? And this is probably what I should have done at the very, very beginning with those e to the negative x. I could do what?
Cancel.
Not cancel them, but,
Natural log.
well, what have I got right there and there? In both parts I have an e to the negative x.
Good factor.
I could factor it out. Okay? Which is probably what I should have done at the beginning before I did all this stuff right here. Because that would have made life a lot easier, wouldn't it?
Yeah, this is ridiculous.
Okay? Okay? So, I'm going to go ahead and do that for both up here. Okay? So, yeah.
It's so hard.
Not hard, it's just long.
You're just do colors, bro.
I should have done it at the beginning because now I can see I just have one product rule there, don't I?
Yeah.
Isn't that just one product rule?
Yeah.
Okay? I'm going to do the same exact thing down here too. Okay? Plus e to the negative x times. Yeah, no, it's one problem. Okay? Now they're both factored. Okay. So now when I take my second derivative, okay, instead of having to do the product rules to all of that there, which would be a product rule, product rule, product rule, product rule, I could just do it to these things down here. Okay, so the second derivative down here would be the derivative of y, which we already got, so it's self-referential. Okay, then the derivative of this guy here, which should just be a simple power rule, because everything's got an order now. Okay? Everyone see that? Okay, so let's go ahead and quickly do that over here. Okay. This is going to be y prime, okay, plus e to the negative x times negative 1 times minus c1 sine of x plus c2 cosine of x, okay, plus e to the negative x times derivative of this right here. What's the derivative of the sine? Cosine, so minus c1 cosine of x. Okay, and the derivative of the cosine is? Negative sine. Minus c2 sine of x. Okay? Which is what? Is it just y? It's negative y. Okay? So all that can become just negative y. And
You didn't change the first part to negative y prime.
Huh?
The first, you never said that, isn't that negative prime also?
right here, oh yeah, I left off the minus, didn't I?
Yeah.
Yes, because it's minus there. Yes, thank you. Okay. Well, that became minus y over here, and so that means that y2 then is equal to y prime, okay, or minus y prime, excuse me. Okay. Minus y, okay, minus e to the negative x times negative c1 sine of x plus c2 cosine of x, okay? Everyone see how that worked right there?
Okay.
Clear stack.
Not cool.
Okay? So at this point here, it would just be going back to my original thing and verifying that indeed all that equals to 0, okay? By just replacing all the pieces that I've got, okay? So, we've got y double prime plus 2y prime plus 2y needs to be equal to 0. Y double prime is given. It's minus y sub 1, okay? Minus y minus e to the negative x times negative c1 sine of x plus c2 cosine of x, okay, plus 2 times what y prime was, which was minus y plus e to the negative x times minus c1 sine of x plus c2 cosine of x, okay? And then plus 2 times what y was, which was e to the negative x times c1 cosine of x plus c2 sine of x, okay? That's all equal to 0.
So here's on the second derivative, how did you go from the x times -1 times that to the y on the far right? So wouldn't that make it plus c1?
Right here?
Wouldn't that make it positive c1 sine x minus, instead of 2 minuses?
Okay, so we went from right here to right here. Okay, so how do we get this part of the derivative? Derivative of the cosine is
It's
minus the sine.
minus the sine.
Okay, so that's how this became minus c2 sine of x,
Oh.
and minus c1 sine of x became minus c1 cosine of x.
What happens to the -1 is in front of this?
What negative?
The -1. E to the x, e to the negative x times -1.
Oh, this right here is a different step. This is one step, and then I ran out of room,
Oh,
so I
so
wrote that step down.
okay, okay.
Yes. Okay. You see how we got all this up here, and now we can just go through and
Could you replace that negative y prime with what you got from y prime?
absolutely I could. Okay, and I could replace the negative y's with what I originally started with. Okay, and so notice what's going to happen there would be that essentially that right there cancels out with all that right there. Okay. I write this one out here. It's the positive c1 cosine of x sine c1 of x, which is, oh, where'd that go? Oh, there's a minus sign right here, so all this cancels with all this, okay? Right there. Didn't even notice that.
Let's see.
And then we have an extra one of those, but that gets canceled out from the y prime, and that got canceled out with the y prime too, so we get 0. Okay, it all does work, okay?
We should get a test that it's only like
Just one question here.
But it has that here.
But, again, okay, notice how, as far as calculus was concerned here, there was some simple product rules we had to do, right? The derivatives weren't hard, it was just the bookkeeping involved, okay? And that's what I kind of want to demonstrate with this problem, okay? So this is why it's very good to go through and label steps and be very clear with your work, okay? Otherwise you end up with a mess like this, okay? And this works, you know, because we color-coded it, and even then it still looks confusing, okay? But it does indeed work out, okay? So, keep that in mind when you're doing these types of problems. This is about, by the way, again, you're not going to actually see something like this, okay? This is like an extreme example, okay, to demonstrate the point. But this is about as far as they get, okay? All right. Any questions there? Okay, well, somebody said they had a question on the homework they wanted to go over real fast. We got 6 minutes, so might as well do it.
I guess now that we put it out, I can like figure it out a little bit.
Okay, well, which problem is it? Because we just look at it anyway.
Can we just go over like some random ones and remember exactly?
Sure.
You just pick a random one from the 1 through 7 and 41 to 51.
Okay, so 1 through 7, we're verifying the solution of the differential equation, okay? So that was exactly what we were doing up there.
Yeah.
However, we're doing the odd ones, and they should be a lot easier than what we were just doing up there, okay? 6 was a doozy, okay? But like number 1, for example, okay? We have y equals c e to the 4x. That doesn't look like c. Y is equal to c e to the 4x, okay? And we want to show that y prime equals 4y, that works, okay? Well, what's my derivative of this guy here? 4c e to the 4x, right? Okay? What's y? this right here, so like quite literally, like if I just replace the y here, aren't those exactly the same thing? Yeah, so it works. Okay, so we just verified. Check mark. Okay, so that's all we had to do there. Okay, so like number one, was just again taking the derivative and showing that it indeed worked. Okay, number three is going to work the same way, although they add an extra layer of making this an implicit differentiation problem. Okay, so let's take a look at how number three works. Okay, we've got x squared plus y squared equals cy, and we want to show that y prime is going to be equal to 2xy divided by x squared minus y squared. Okay? So let's go through this,
Oh, well, yeah, this is wrong.
okay,
Maybe.
and work this through and show you how it works out this way. Okay. First thing I'm going to do here. Okay, we're going to want to do some rewriting here. Okay. We want to get. Well,
Y by itself?
Wait, can't you like factor x squared minus y squared into like x plus y times x minus y and then sort of
and do it that way? You could. It's not going to really help you out. I think what we're just going to start off with here, to be honest with you, is I think we're going to take the derivative of this guy right here and see how I can rewrite it to be like this right here. Because all this is asking me to do is just basically show that this is the case. Okay? So what's my derivative here if I do things implicitly? Derivative of x squared should be 2x, okay, plus 2y, y prime. Okay?
Y prime.
What's the derivative of y?
Y.
Implicitly, guys.
What's the differentiation? It's y.
Okay. Remember, okay, we've got x's and y's in this equation mixed up together,
Oh yeah,
right?
the dy over.
So yeah, okay, so whenever we hit a y, you take the derivative of it, you have to add on that extra step. It's equal to
Oh,
c
yeah.
times
You just
y
isolate
prime, right?
Y prime. Okay.
Okay.
How'd you get 2y prime?
Okay, y squared. What's the derivative of y squared?
2y.
2y
Attached to y prime.
Times
dy or dx.
dy or dx, which is y prime in this case. Okay? And remember, that's how implicit differentiation works. So that implicit stuff comes back. Okay, a lot of times in these things. Okay? Alright, so now it's just a matter of cleaning this thing up to try to get it to equal what's on the other side here. Ooh, we're out of time. Okay, so that'd be something we would just work on doing. Okay? Alright. We can finish this one up tomorrow. We'll look at it again tomorrow.